My name is Saul.
And my name's Lucas.
And we decided to find the volume of food items.
Such as this loaf of bread.
Let's have a loaf of bread.
Half a loaf of bread.
Because we cut it in half to determine the volume of it based on solids of revolution calculus technique.
So what we did, we just plotted half of this loaf.
We traced the loaf of bread on a piece of paper and added axes. Then we plotted some points on the outline of the loaf, and we found equations in a computer program to model the top set of points and the bottom set of points.
If this is our function, this is a graph, these are the axes, and this is our loaf of bread here. This is half of our profile. This is our axis of rotation right here. This is at 4 inches. This is 0 inches. So our loaf of bread is about 4 inches in radius. This top function is different from this bottom function because if they were the same function, they wouldn't actually be a function, so it would fail the vertical line test. Next, what we did. So we plotted these two things. We'll call this f of x for the top function, the FOP function, and this is g of x for the bottom function, or bottom function. Next, we wrote an equation, an integral, in this form. So we have the integral from, now actually this value right here is 0.3. That's just how we graphed it. From 0.3 to 4 of 2 pi times the height, f of x minus g of x, times the radius, which is x minus 4, times the width of each strip, which is dx. So we have a strip here, parallel to the axis of rotation. Its width would be dx.
Lucas, could you please tell me what the 2 pi represents in that function?
The 2 pi represents circumference. So you're adding up all the, I don't know what that represents, actually.
No, that's right. no, I think that's right.
It represents circumference.
Because
So
2 pi is pi.
You're finding the area. So if this is 2 pi r, that's the circumference, times the height is going to give you the full area of sort of that cylinder.
I see.
Times the width. So the volume of that cylinder. And this integral is saying we're going to take all of these and add them together.
So you're making you're basically saying you're making a circumference at that line around the axis of rotation, and then you're the width of that circumference is dx, so it's like a little bit of a thick circumference, and then you're raising it the height of f of x minus g of x.
Correct.
Oh. Okay.
So, for our regression model for our bread, we decided for the top of the bread to do a quadratic equation because it has this nice flow to it like this that kind of looks like quadratic. For the bottom was a little bit more irregular, so we decided to go with a quartic polynomial because really, why not?
Because it modeled the bottom of the loaf pretty well, actually.
Yeah.
The loaf levels off.
Very nice bottom of the loaf.
It goes
level.
from
very nice leveling.
from a very steep angle here and then very flat. And a quartic polynomial can map that kind of function very nicely.
In Mathematica here, you can see that we entered our data for our bread. These are the points that we found. And here they are plotted on a graph along with our fit lines that we've generated. And then if we go down further, we can see the actual integral that computes the area, or sorry, the volume of this 3D shape. And this uses those lines that are those regression lines that we found earlier. So this equation here gives us the answer of 124 cubic inches for the volume of this loaf of bread.
It's like that. Ready? We're filming?
I'm filming.
Okay, this is a three-dimensional graph of the loaf of bread. This right here is the loaf of bread. They are very similar in almost every way, including color. We made the graph on a computer program called Mathematica, which we also used to figure out the volume and whatnot.
The point of this project was to determine how many inches cubed of bread a human eats per second when forced to eat bread at an uncomfortable pace. So I'll be performing the second part of this experiment, where I eat half of this loaf of bread, and we use the volume we figured out to determine the number of inches cubed per second that a human eats of bread. So I'm just going to start eating this. Got some raisin.
It's got nuts in it too, I think. We're gonna take forever, dude. I brought this bucket so you could use it.
And 15 minutes later, quarter of a loaf, eaten by Saul Shanbrook. Normal human being, uncomfortably fast, bread intake. Done. So we started out with 124 inches cubed of bread. But I actually only ate a quarter of that, so I ate 124 divided by 4 inches cubed of bread. And that took me about 15 minutes to eat. Let's see what that rate is like. Let's see. So, normal person eats their bread at about 2 inches cubed per minute. And this is all based on calculus. So thanks.